Okay, so in this video, we are going to finish the problem that we started in the last video, um, which is to minimize the surface area of the can that can hold 1,000 cubic centimeters of oil. So we've got our surface area function, which was what we did in the last video. And we're going to find a minimum value where at critical values. And I guess at critical values, we're looking for either f prime of r is equal to 0 or f prime of r does not exist. Either way, we got to take the derivative. So I take the derivative of my function, and it's just power rule. So I get f prime of r is 4 pi r minus 2,000 over r squared. So I guess we would say f prime of r is going to not exist. When r is equal to 0, but from our domain, that's not in our domain anyway. So we don't care. So what I do care about is where f prime of r is equal to 0. R when 4 pi r minus 2,000 over r squared is equal to 0. So I suppose we're going to multiply both sides of this function by r squared to clear that denominator. So I'll have 4, let's go back to black. So I'll have 4 pi r cubed minus 2,000 is equal to 0. I guess that's 4 pi r cubed is equal to 2,000. We'll divide both sides by 4 pi. Let me see, 2,000 divided by 4 is going to be 500. Then we'll take the cube root. And there we go. R is the cubed root of 500 over pi. Let's see. Did it only ask for the radius? No, it asked for the dimensions. Okay, so that means we also want to find h. H is 1,000 over pi r squared. And, oops. Geez, I guess we'll just plug all this stuff in, huh? So that's going to be 1,000 over pi times 500 over pi to the 3/2. And it's okay if we just leave it like that. We leave these things in exact form. So there is our answer. There's your R, there's your H. The one last thing we have to do is verify that this is indeed a minimum. Now there's two ways to do that. One is with a sign chart. We cannot use a table method by plugging values back in because we don't have an upper bound. And now this number is kind of messy, But if we're looking back, all we really care is that is my derivative positive or negative? And if you look, if you plug in a large number, well, this 4 pi r bit is going to be very big. And this 2000 over r squared is going to be very small. And if I take a big number minus a small number, I get something positive, right? And if my derivative is positive, my function must be increasing. And now when I have a really small number, 4 pi r squared is going to be very small. And if you divide by a very small number, you're going to get something big. And if I take a small number minus a big number, I get something negative. And so my function must be decreasing. And if I decrease before this number and increase after this number, it must be indeed a minimum. So good. Another way I could do this, also valid, is to take the second derivative. And you'll notice for all positive r, which is the only r's we're interested in, this second derivative is going to be positive. And if the second derivative is positive, that means this function is always concave up. And if it's concave up, the one place where I had my critical value must have been a minimum. All right. So there we go. I'll just get it all in one screen for a second so y'all could take a look at it. But all right. Thank you.